All right, so in this video, I'm going to look at examples 4 through 6. Just wanted to do several of these so you kind of got the sense of the process. It's really not as hard as it seems. Okay, so on this one, I'm changing the terminology. Rather than saying solve, this problem says find the zeros. Basically the same thing though. They just use that word because it had function notation in it. So basically your first step is to convert it into a polynomial equation. So you set it equal to 0. Then they're not giving you a hint about what's going to work. So you have to do the possible rational zero concept. You have to get a list of possible rational zeros for you to test. And I guess I can use roots since I switched it over into an equation. So the possible rational roots come from taking the factors of 8 divided by the factors of 2, and make sure you do plus or minus on all of them. So that's plus or minus 1, 2, 4, and 8, and then over plus or minus 1 and 2. So it's factors of 8 over factors of 2. Now I got to say 1 over 1, 2 over 1, 4 over 1, 8 over 1. So 1, 2, 4, and 8 plus or minus on each of those. And then 1 over 2 would be a half. Now when I go and do 2 over 2, I've already got that because that's simplified to 1. When I do 4 over 2, I've already got that because that's simplified to 2. And when I do 8 over 2, I already have that because that simplifies to 4. So I have these 10 possibilities, the 5 positive ones and the 5 negative. Okay, and then notice it's degree 3. Okay, so there's 3 roots or zeros. Okay, and I need one nice one so that I can then get the quadratic factor. So I'm going to start testing. There's no missing terms here. So I'm just going to set it up. Don't forget to include the negatives that you saw there, and then do the process. Okay, so 2, it's negative 11. Nope. Okay, so that one didn't work. So then I might at that point either try 2 or try negative 1. Okay. And sometimes I do both the positive and the negative with one set up and just adjust the signs. Okay, so I could do this. Nope, that's way off. Okay, so those didn't work. Let me try 2. Okay, so that's 2, that's 4. Negative 9, it's negative 18, it's positive 4. Good. All right, so that one worked. So it worked. Okay, so that means right here is my quadratic factor, with that being my A, my B, and my C. Okay, so you can look at it for a moment, maybe try factoring it, because maybe it does factor. Okay, so maybe give it a shot. Ooh, I'm thinking it might. If I put a 4 there, and a 1 there, that'll be 8. That'll be 1x. So if I can make those both negative, yep, I can. That's it. So that one I just kind of tried the factoring a little bit more than I had on the others. And it worked. So now I'm ready to set those equal to 0. Okay, and finish it up. And I wind up then with 1/2 and 4 coming from the quadratic factor. Okay, so then you have to put it all together. So your solutions to this one, the zeros turned out to be 2 worked, and then we had the quadratic factor left over, and that gave us the other 2 solutions. So like somebody might have tested 4 in their synthetic division, they would have found that it worked, and then they could go from there and find the other 2 solutions. So there's no, you don't have to start with the smallest numbers. I just normally systematically start with the smaller ones and move from there, okay? All right, so let's try another one. See how the process is feeling very very much the same. This one also is starting with the function, and the directions are to find the zeros. Okay, this one is degree 4. Okay, so I have 4 zeros. So I need 2 that work using the synthetic division. The possible rational ones are going to come from factors of 16. And since that's a 1 out in front, doesn't really add anything to that. So it'd be plus or minus 1, 2, 4, 8, and 16, because they're all over just 1. So these are what I'm testing. I need 2 that work. I'm just going to get started. Otherwise, I don't know what to do. Okay. And I usually just start at the left and move to the right, but there's no real reason for that. Okay, there's no real knowledge going in there. Okay, that doesn't work. Okay, let me try -1. Make sure you're including the correct signs on everything. Okay, that one worked. All right, so this one works. And so now I'm going to kind of start from there and be trying some others. So +1 was out the first time. I'm not going to try it again, but I might move on and try, say, 2 from here. All right, so let's see if 2 works and see how I start where I left off. So that's 1, it's 4. That'd be -12. Okay, nope, that doesn't work. So keep starting from where you left off. Now, sometimes I do this. Let me share that with you. 2 didn't work, but maybe -2 would. So sometimes right on that same one, I put the -2 in, and I kind of see if it would work. Nope, it's not going to work either. And then maybe I'll move on then. So I'm going to try a 4 from where those 4 ones. Let me try it, see if it works. Here I make a mistake a lot of times, and I'll say 8. I'm adding straight down. Okay, that's 4. Okay. Oh, yay. That one works. You know, and I meant to get in the habit of, when they work, of circling them so I don't lose where they are. So see how I started with the original polynomial, and then I was down here to 4 numbers? That was because this started out as an x to the 4th. I was dividing by x plus 1, really. This got me down to an x to the 3rd. Okay. Then I had another x I was dividing by. This, remember, was x to the 3rd. So now I'm down to an x to the 2nd. So see how you have those 3 things? That's your A, your B, and your C. Right? And I can tell this is not going to factor. See, I can't break up 4 and get any way of making the 6 happen. So I'm going to go ahead and use the quadratic formula. So plug in your A, your B, and your C into the quadratic formula. Let me check that, because I can't do this very well if I'm talking. Yep, that looks okay. All right, so that's 36 minus 16. Let's see if I can erase a little bit on that. Okay, so that winds up being -6 plus or minus the square root of 20 over 2. Okay. And simplifying the square root of 20, remember how that's 4 times 5, so that would be 2 square root of 5, and then 2 goes into both of those, so that would be -3 plus or minus the square root of 5. Okay, so one of my solutions was -1. Then 4 worked, and then I got -3 plus square root of 5 and -3 minus square root of 5. Okay, and see how those came in that kind of look like conjugate pairs? They're very similar, just a change in sign. That's going to happen if your polynomial had nice coefficients. That's what's going to happen. Okay. All right, and then let's try one more. This one is also degree 4. Okay. Seems like the one I had on the previous page, is it? No, but it's a lot like it. All right, so this one is f of x equals 2x to the fourth plus 17x to the third plus 58x squared plus 77x plus 26. So the possible zeros, rational zeros, are going to be plus or minus 1, 2, 13, and 26 over plus or minus 1, plus or minus 2. So we're going to have several possibilities. So 1, plus or minus 1, plus or minus 2, 13, and 26, but then also plus or minus 1/2. 2 over 2 would still be 1, 13 over 2, and then 26 over 2 would be 13. So we'd have to try all of these. Okay, we don't have to try them all, but we need to use those. And think about how many we need to work. So this is question number 6 right here. It's degree 4, so we need 2 to work, 2 nice ones. Okay, so then get busy, because this can take a little bit of time, but if you're, synthetic division is very fast. So you need to be good at it, have done it a lot, so that you don't feel bogged down here. Okay, this is getting big, but that's a big number there, so maybe I'll be okay. 77. No, it's getting bigger. But now what I usually do at that point is I put the negative on it. So that's 2, then negative 2 would be 15. This would be negative 15. So what's that? That's going to be 43, which would be negative 43, and then 7 minus 3 is 4. 7 minus 4 is 3. Nope. Okay, so neither 1 or negative 1 works. Okay, so let me try 2. So I'm going to put that in. And I'm trying to work these without knowing what the answer is ahead of time. Okay, so that would be 4. So that's going to be 11, 21. So that's going to be 40. See, I don't see any way. Do you see how there's no way to get it? This is just getting bigger and bigger and bigger as you go across. So I feel like there's not going to be a positive one. They're going to be negative. So I think I'm going to abandon that. You see what I mean? See, when you do that, that's going to be 42. That's going to be big. That's going to be big, big. So I know that's not going to work. So let's go ahead and put a negative on that. Okay, that gets me down to 13. That gets me here to negative 26. Okay, that gets me to negative 64. And then that gives me negative 26. So there you got one that works. Let me get in that habit of circling it. So I know positive 2 didn't, negative 2 worked though. Okay, so then we keep trying, and I don't like what happens when I try positive ones. Did you see how they just kept getting bigger and bigger and bigger? So I'm going to try a negative 13. Okay, and let me start from where I left off, which was the 2. So I'm looking from where I left off. In fact, I should just do it there. Okay, let's just set it up right there. So I'm going to try a negative 13 from right here. Okay, so that's 2. And then this would be negative 26. So that would be negative 13. Then, okay, already that's like 169. That's going to be too big. So that doesn't look good. And once I saw that those numbers got kind of big, maybe I'm going to go try some of these fractions. And let me try a half. Oops. Shoot. Sorry, guys. I'm kind of flustered with my video not working earlier. I'm kind of behind. So I've got 2, 13, 32, and 13. That's where I left off before. So let me start from there. So 2 is 1. Half of 14 is 7. So that gets me to 39. And I can't do half of the 39 and get 13. Okay, so that's not working so well. Okay, let me try a negative 1/2. So I'm trying to give you an authentic feel. This is what can happen. There's nobody can tell you right off the bat whether something works or not. Okay, So that's going to be 6 from there would be 26, and then half of that would be negative 13. Okay, that one works. I know that this is giving me one of the solutions, okay? So we needed 2 that worked, right? We got the 2 that works. See, what happens now is we're down to only the 3, so this is quadratic, and so this is 2x squared plus 12x plus 26, and I'm ready to solve that. I might try to factor it. If I divided by 2 everywhere, what does 2 go in there? 13 times. Could do that. Okay, but I can tell, all I did is I noticed it was even, so I divided everywhere by 2 because I'm allowed to. So if you notice that, you can make it have smaller numbers, but then I can see I need to use the quadratic formula. So that's what I'm going to do. Okay, and so the quadratic formula you need to be really good at. We worked at that at the start, and then synthetic division. And if you can do those 2 things, you're home free. So that's negative 6 plus or minus square root, and what is that? Negative 16, it looks like. Okay, so that'll be negative 6 plus or minus 4i over 2, which will be negative 3 plus or minus 2i. All right, so let me collect all of that. So I had a negative 1/2. What was the other one? Negative 2. Then I just had a negative 3 plus 2i and a negative 3 minus 2i. So I had 4 solutions that I was expecting, and there they are. Okay, and those would be the zeros of the polynomial. Okay, so I just wanted to run through. Now we've done like 6 examples, so you kind of get a sense of how that works.